Welcome once again to Electcom Automation. Today we are going to learn how to use a contactor selective switch start and stop button to manually and automatically pump our water. Now, these are the components that we need to use to complete this automation. Now, let me explain each part of the component. This is a circuit breaker. Circuit breaker is just a switch that allows the flow of current from the input to the output. This is my contactor. You check my previous video, you see explanation of a contactor. This is a selective switch gear. Is there in my video. You can check how to use a selective switch gear. This is start and stop button. Start and stop button. I've also explained it in my previous video. And this is float switch with a zinc knob. So you check a previous video, you also see a float switch, but we are going to do different automation entirely to help us manually and automatically pump our water without any helping hands. Now let's check how the circuit breaker is used. This is just my power cord for voltage input. So let's explain the circuit breaker. I've turned on my meter. So you can see means that it's reading. So I want to check how the current flow from the circuit breaker. So what do I do? Alright, so this is the input of the circuit breaker and this is the output. So that means that the circuit breaker at this point is off. So this is the input and this is the output. That means it's off. So if I keep it at this position, it means that there is a flow of current from this end to this end now. So the same thing here, means that it's connected from here to here. So if I drop it down, there's no flow of current. So that means that if we put our main voltage input here, we'll get the output from this side when we keep the knob direction, the switch position at this point. Now let me bring in my voltage input here so that we can get output here. So I'll slide it to input my voltage. Alright, so this is my power cable and this is my voltage in. There is a live entering this other side. Good, so I'm done with that. So I'm going to put the neutral cable. So this is the neutral, putting it here. This is the neutral, so I've slot it down here. Oh. Alright, I'm done with that. So the next thing is to take out from the circuit breaker output to our selective switch gear so that we can manually and automatically control the output load. So let me take from the circuit breaker down to the selective switch gear. Now before connecting it from the circuit breaker to the selective switch gear, we need to also check the operation of the selective switch gear, which side is on position and which side is off position. Okay, how to do that is to use your multimeter to carry out that experiment. So I'm going to use my ohmmeter to carry out the experiment. So if it's at 0, I explained this in my previous video. If the selective switch gear is at 0, it means that the two side is totally isolated. But if it's at 1, it means that one side is connected and the other side is isolated. But if it is at 2, it means that at 2 position, the two side is connected and the one side is isolated. So let's see how this works. Means that at 1, this is 1, means that at 0, this is 0, this side is isolated, everywhere is isolated, totally isolated. There is no way that is connected. Isolated, isolated, isolated. But if I keep it at 1, 1 simply means that one side is connected and the other side is isolated. So as you can see, all this side is isolated. So let's check this side. All right, this side is connected. So it's connected. So if you check here, it's not connected. So it's connected at this point. It's connected at this point. That means it's from here to here, from here to here, from this point to this point. Why we are having the three is this selective switch here is a three-phase selective voltage switch here. So if it was single phase, you would have one, and if it was a two-phase, you would have two. So now that is three-phase, you can use a three-phase voltage supply. But in this case, I want to use only a single-phase voltage supply. So I will take this one to be my live supply wire. So I will take this one to be my voltage neutral. So this one will be my live neutral, and this one will be my voltage neutral. This one will be my live wire voltage input, whereas here will be the live wire voltage output. So here will be my main neutral input, and here will be my main neutral output. So that is just how the switch is working, because when it enter here, it's going out from this position, like from here to here is connected. But if when it is at one position, if I turn it to this other phase, you see that this side is isolated. No way is connected at this point until when I turn it back to two position. No, it's at one position now. So if I turn it back to two position, that is when this side is connected. Then it's connected. Then if you turn to this other side will automatically be isolated. Let's see, it's isolated. Good. So that is how that switch J, this is how the switch J is operating. So now let's connect the cable from the circuit breaker to the switch J. This is my circuit breaker input. So this is the output from the circuit breaker. So I have slotted it down here. All right, so I'm done with that. So I'm going to also slot in the neutral output from the circuit breaker. So all right, I'm done with that. So I need to connect from the circuit breaker down to the selective switch J. So how do I do that? Since I know that if I input here, I'm going to get the output here. This switch J uses three phase, but I want to use single phase to connect it. So, and I want to control with only one voltage supply. But in your case, you can use your generator in this side. That will be your generator input and your generator output. You can put your NEPA input here and your NEPA output. But in this case, I want to use only NEPA input. If my NEPA input is at this point, I can loop from this point to this point to get a supply to here. That means if I input here, I loop to this point, means that there is NEPA input also at this point to supply a voltage to knob 2. So let's see how to do that. So I will just connect my voltage input at this point. That is my voltage input. So I need a jumper to loop from here to this point to give a supply to this other phase. So I'm going to bring my jumper. So this is my jumper. I'm going to loop from this position down to this position. To do is to screw it down, screw it down. This simply means that I've successfully looped a live main input from this phase to this other phase. So I will do the same to the neutral side. So how do we do the looping? So I'm going to loop from here to here. See. So alright, so I'm done with the looping. So you can see I've looped this phase to this other phase to give a supply to this side, and I've looped from here to here to give a supply to this side. So the next thing that I'm going to do is for me to connect the input. That is the input voltage. So I'm going to connect the output to my load. I'm going to also connect this when it's at position 1, and this is when it's at 2. So I'm going to connect this output to different voltage supply. So let me do the connection. And as I told you earlier, say we are going to use a start and stop button to manually control the pump of water. And when you press the start button, you manually pump the water and you press the stop to stop pumping the water. And we are also going to use a float switch to automatically pump the water. That is, when the water fill up the tank, the float switch will automatically stop pumping the water, and when there is no water in the tank, the float switch will automatically start pumping the water. So let's connect the start and stop button to the switch here. So this is my start button and this is my stop button. So my start button at the initial stage is always normally open, whereas the stop button at initial condition is always normally closed. So when you press it down, that is when it's going to start, and that is when the terminal is connected, and here is always connected at initial condition, but when you press it down, it will disconnect, and when you leave it, it will connect and allow voltage to pass through it. Check our previous video, you will see the explanation of this start and stop button. Okay, so let's connect the start and stop button together. So I'm going to do the connection like this. You have seen terminal 1 and terminal 3 should be connected together. So we have 1 and 3. So let's do the connection. All right, so I'm going to connect terminal 1 of the start button to terminal 3 of the stop button. So this is terminal 1 of the stop button, so I'm connecting it at this point. So I'm going to connect it to terminal 3 of the start button. So at this 3 position, if I'm connecting it here, then I will loop and bring a voltage supply at this point, so that from here to here the voltage will flow between here and here, so that if you press it, the switch will turn on, and if you press it at this point, it will stop. So I'm going to connect the voltage supply here. So I'm going to use a live wire to bring a light from one phase of the switch here down to this point. So this is my live wire, so I'm slotting it down here to loop the voltage. All right, so I'm done with that. So I'm going to take it to the selective switch here. So I'm taking it to the switch here, one side of the selective switch here. So this is the phases output of the selective switch here. So I'm going to connect it at this point, so that we can use the switch to manually pump the water. So I'm connecting it at this point, then that at that position we will manually control the pump of the water in the tank. All right, so that is how it is. So now I'm going to connect a flow switch as another switch now, so that we can use it to automatically pump the water. So I'm going to connect the live wire of the flow switch to the selective switch here. But before doing the connection, when the flow switch is at this position, it means that the water are full the tank, but when it is at down, it means that there's no water, so the water should start pumping. And how do I know that? Is from this terminal of the flow switch, we have the normally open, we have my common, and we have normally closed. So if I slot this is what we use to determine at what point the flow switch should zinc and stop floating, so as to take the knob up or take it down for the pump of water. So if it's at this position, means from here, from this point, means that it should be at this point. So when there is no water, you have something like this, but when the water fill up the tank, the float switch will start bending till at this position the water will start pumping. So I hope you understand. So what do? I'm going to tie this at this point. Tie it here. All right, so I'm done with that. So the next thing is to identify these terminals of this flow switch. So I'm going to use my meter to do the identification of this terminal from the flow switch. So this is my common, to show you that this is a common. So I keep this here. So is not connected. Therefore, this contact of the flow switch is normally open. This one is reading, means that this contact of the flow switch is normally closed. So that means as it's dropping down, this is the position that is reading at this position now. So it's at this position, up, facing up. It's normally here, the red is normally closed and the blue is normally open, meaning that the water has filled the tank. But when it's down, means that here is now normally open and here the blue is now normally closed. So therefore, we want the water to start pumping when the knob is facing down. So then that means that we are going to use the normally open terminal of the flow switch to do the connection. So let's do that. Since we are not using the normally closed terminal of the flow switch, we are going to insulate the normally closed terminal of the flow switch. So let me do that quickly. So just follow me, let's do it together. So this is my insulation tape. So I'm going to use the insulation tape to insulate that point that we are not using. So this is a normally open, so I'm going to insulate it at this point. All right, so that is done. So I'm going to connect this terminal of the selective switch J, which is the common. I'm going to connect the common to the selective switch J. So I'm going to use a jumper to do that. This is my common. This is the selective switch J. Note that this phase, we take this phase to go to our start and stop button. So therefore means that this phase output should go to our selective, should go to our flow switch. So I'm using this point now. So I'm connecting the flow switch at this point. I'm going to slap it down also. All right, I'm done with that. Okay, so the next thing now is to connect the common of the flow switch, that is the normally open terminal of the flow switch, out, so that we'll use it for our load connection. So I'm done with that. I need to insulate it at that point. All right, so I'm done insulating it. So the next thing now is to connect. This is my flow switch, pin it that way. So I'm done with the connection of the flow switch. So the next thing is to connect the neutral. So I've looped the neutral also together, as you can see. So I'm going to connect the neutral out to the contactor. So this is my neutral. So I'll look for a cable for the neutral connection. So I'm using this cable now to connect the neutral. So this way, the neutral, this is where I'm connecting the neutral. So I'm connecting it at this point. That is the neutral output of the flow switch. Alright, so I'm done connecting the neutral. So we'll also do the same thing to the other side. You know, we did not connect the neutral from the start button side, so let me go and connect the neutral at that position also. All right, so I'm done with that. So next thing is to connect the neutral of the flow switch. So I'm going to use this cable to connect this phase neutral out, using this cable to connect it out. All right, so I'm done with that. All right, so since I'm done with that connection, the next thing now is to connect the output load to the contactor, because it's the contactor that we use in that switching. So I'm going to connect the output load to the contactor. All right, so this is my contactor. So I wish to show you how the circuit diagram of the one that I've just done, how it look like. So you have seen how we connect the contactor and the switch J from our previous video. So what I'm going to do is to connect this is the coil contact of the contactor, which is the A1 and the A2. So you know that when the contact of the contactor, the coil contact, is being energized, the normally open contact of the contactor will turn normally close, and the normally closed contact will turn normally open. So, and you notice that as soon as the coil contact of the contactor is being energized, this knob will drop down to allow the easy flow of current from the normally open contact, that is here to here. And this contact have a neutral terminal at this point, connected also to a neutral terminal at this other side. So if you connect the neutral here or you connect it here, it's still going to work the same. So I want to connect mine here. So okay, let me first slot in the live from the flow switch. So this was my flow switch. This was the live output from the flow switch. So I'm connecting it at this point, the flow switch. So I'm connecting it at this point. Just follow the connection, you get it, slowly one after the other. So it's at this position now. So the next thing now is to connect also connect the one from my start button to the contactor. So I'm going to terminate at this point. So you see at terminal 4 of my start button to the contactor. So this is my terminal 4 of the start button. So alright, I'm done with that. So I'm going to connect it to my coil contact of the contactor, because it's a live wire that is coming from there. So I'm going to connect it here, and after connecting it to the coil contact of the contactor, I will loop it to the normally open contact to create a holding contact for the start and stop button. So I'm connecting it at this point again. So I'm going to flag it back. Therefore means that the live cable that is coming from the flow switch and the one that is coming from the start and stop button is being connected together, and they loop to the normally open contact of the contactor. So connecting it here together at this point. Good. So it's at this position now. That is a live wire from the switch J, selective switch J, and from the flow switch from the start button. So I'm going to loop from this A1 now to the normally open contact of the contactor to create a holding contact. So let's do that together. I'm going to loop from here to this point. That is to create a holding contact for the start and stop button. That is for the start of the contactor. Alright, so to create that same holding contact for the stop button of the contactor, I'm going to loop from this other side of the stop button of the contactor to the normally open contact also of the contactor. So I select it. That is my terminal 2 of the stop button. So this is the cable that I want to use in that looping. That is my terminal 2. You know that stop button is always normally closed, initial condition. So that is it. So I'm going to take it to contactor normally open. Know that the first one was from my A1 contact to normally open 13, and from that one was from start button, and this one is from stop button. So stop button to normally open contact 14. So at contact 14, my contactor. Alright, so I'm done with that. So the next thing now is to connect my load. So by so doing, I have created a holding contact to start and stop the contactor when there is a voltage supply to the start and stop button, and I've also created a holding contact to start and stop the contactor when there is a voltage supply to the common of the switch of the float switch, when there's a voltage supply to the common of the float switch. Now let me connect my load to the contactor, which is going to be my zoomer. So you bring your zoomer. So in this case, I want to use this lamp to represent my zoomer. So I'm going to connect the zoomer. So you connect the zoomer live to T1, because T1 is always output while L1 is input. So I'm going to connect my zoomer 1 to T1 of the contactor. Connecting my zoomer live to T1 of the contactor. Is T1 of the contactor. So connecting my zoomer live output from there. So I want to connect the neutral. This is my zoomer neutral. So I'm going to connect it to the neutral contact of the contactor. I told you earlier that if you are using this side, it's still the same neutral. So I'm going to connect the neutral here. That is the neutral of the contactor. So I'm done connecting it to the neutral of the zoomer load. That is my load. So I'm done with that. So the next thing is to bring in the supply to T1 of the zoomer. So I'm going to use the supply is at, you either take it from normally open contact or you take it from here. So I'm going to take from my live supply now to T1. So let's do the connection together quickly. Alright, so I'm done plugging it back again. So I want to connect a supply from that point. So I'm going to take it to L1. This is the L1 from the contactor. So I'm connecting it at this point now at L1 of the contactor. So this is it, from A1 to L1 of the contactor. Alright, I'm done with that connection also. So the next thing is to do the same to the neutral, and this was the neutral that was coming from the float from the selective switch J, and this was another neutral. So all the neutral, I'm going to terminate it together. So let's do that together. This is my first neutral input, and this is my second neutral. So I'm going to connect this neutral also to L3. So if I'm connecting it to L3, there is no need for that because I've already connected a neutral from A2 contact to the load from that other side of the contactor. So all I need to do now is to connect these two neutral together at this point. Alright, so I'm done with that connection. So I'm going to bring everything back again. So done with all the necessary connection. So all I need to do is to power and see the behavior. So this is the lamp. Going to power now to see the behavior. This is the start button, this is the stop button, this is the float switch, this is my circuit breaker. So first, before we start, I need to see whether there is a voltage in at the circuit breaker. So let me connect it to bring the voltage input. Alright, from my meter it's telling me that there is a current flow. So I'm going to check if there is a voltage. So I'm going to use my multimeter to check the voltage. So I'm turning it to AC voltage. I'm going to turn my meter to AC voltage. So from my meter, this is my DC volt, and here is my AC voltage from my meter. So let me test it to see the voltage. So alright, I'm having up to 196 volts. That's good. So let me power. See, we are done with all the connection, and the selected switch here is at one position, meaning that I want to manually start pumping the water by clicking start button, and by clicking start button to energize the coil contact of the contactor, and to also manually stop pumping the water by clicking the stop button to de-energize the coil contact of the contactor which our load is connected to. And our load is always our Zumo, but in this case I'm using this AC bulb. So in your own case, you connect your Zumo to where we are connecting the AC bulb to. So I'm going to start pumping the water manually. You can see I've started pumping the water manually, and I'm going to use the stop button to stop pumping the water manually. So that is how the operation is manually used to pump and to stop pumping the water. Start pumping the water, I click the start button to start pumping the water, and I click stop button to stop pumping the water. When we are at that position, the flow switch cannot pump the water, because at that position we want to manually start pumping the water. So as you can see, the flow switch is not working at that time. So also when you turn the position of the switch to 0, it means that you have isolated the two phases. That means that the flow switch will not pump the water, nor the start button and the stop button will pump the water. So as you can see, nothing is working here. So we want to put it at position 2. So at position 2 simply means that we are going to use the flow switch to start pumping the water. So it means at this position, this is where the flow switch is facing down, means that the water are finished in the tank. So we want the water to start pumping. So once the water fill the tank, you see that the flow switch will move to this other up position, and it will stop pumping the water immediately when it's face up. So that is it. So the water have just stopped pumping, and when you drop down again, the water will automatically start pumping. You don't need to start and stop using a switch J. So that is how you use the flow switch to start and stop pumping the water. So at this time, you notice that when you press the start and stop button, it's not working at all. That simply means that we are not manually control the pumping of the water by pressing the start and stop button. Rather, we automatically control the pumping of water by using a sensor called a flow switch to pump the water when there is no water in the tank, and also to stop pumping the water when water fill up the tank. So we'll pump the water when there is no water in the tank, and we'll also stop pumping the water when the water fill up the tank using the sensor called a flow switch. Also, we can also change the position of the flow switch of the selective switch J. We change the position of selective switch J to use the start and stop button to pump the water manually. So we click on the start button to manually start pumping the water, and we click on the stop button to manually stop pumping the water. So I hope you understand the video very well. If there is any question, feel free to drop it at our comment section. We'll do well to answer all your questions. And if there is any reference to our video, check on our previous video to get all explanation of each of the component that is here. We have a contactor explanation, we have the flow switch explanation from our previous video, we have the explanation of start and stop button from our previous video. We also have the explanation of a selective switch J from our previous video. So do well to visit our previous videos to be guided in everything you are going to do about the start and stop button and the control of the switch J, and also the pumping of the water using start and stop button to manually control the pumping of the water.